All right, so let's start the next page of our notes here for thermochemistry, and this is actually going to be the AP connection. And when we first talk about the AP connection, I'm going to take you back to delta H, delta S, and delta G, and we're going to talk about those a little bit. Delta H is enthalpy, and again, the delta means change in, so we have the change in enthalpy. Delta S is entropy, and delta G is free energy. And I'm going to put free energy, and right beside it I'm going to put spontaneous. Spontaneity is what it would be, but let's just put spontaneous. Enthalpy would be heat, and entropy, let's put chaos. Chaos or disorder, that's the key here. So if it's enthalpy and we have negative delta H, then actually, I don't have a way to erase this one. Let's put negative up here and positive over here. So I'll make a little T-chart here. So if it's negative delta H, it's exothermic, and if it's positive delta H, it's endothermic. If it's negative entropy, there's less chaos. And if it's positive entropy, there's more chaos or disorder. Again, disorder means the randomness. How are the molecules organized? Less chaos, more organization is what that means. So more chaos means less organization. Yeah, you guys get that? And then if we're talking about delta G, if it's negative delta G, it's spontaneous. And if it's positive delta G, it's not spontaneous. And again, spontaneous means, hey, if I kickstart this reaction, once I kick it started, I give it a little bit of energy to start up, will it continue on its own? So that's what these are talking about right here. And there are a couple of things I want to point out more here. And these are things that people kind of get confused about because a lot of times they're counterintuitive. So I'm going to put solid, liquid, gas, and I'm going to put an arrow going up this way. So this is changing from a solid to a liquid to a gas, and then I'm going to put an arrow going down this way, and this is changing from a gas down to a liquid down to a solid. Okay, so let's look at delta H and delta S. Which is more chaotic, the molecules in a solid or the molecules in a gas? Well, the molecules in a gas are more chaotic. So as we go from a change from a solid to a liquid to a gas, what we have is positive delta S. It becomes more disordered. That means going back the other way has to be a negative delta S. It becomes less chaotic as you go from a gas down to a liquid down to a solid, right? Now we can look also at delta H. Here, as we change from a solid to a liquid to a gas, don't you have to put heat into the solid? Think ice. Don't you have to put heat into it to get it to change from a solid to a liquid? We put heat in. When you put heat in, that's going to be a positive delta H. It's an endothermic reaction. Positive delta H is endothermic. It's going to absorb the energy. And that makes sense because think about here, we have a solid, and then compare that to a liquid, a lot more energy in the liquid molecules and even more energy in the gas molecules. That means going back down, the gas doesn't have to cool down. And when it cools down, it dumps heat out. And so this is a negative delta H. It gives off heat. It's dumping it out. This is exothermic. Again, a lot of times when people first start learning this, they think, ooh, exothermic, it's going to be a hot, I can feel heat, and endothermic, I can feel it being cold. That's a very limited application. So don't get carried away with that application at all. Now, there is a chart that I make my AP students learn how to draw that kind of helps with all this delta G, delta S, and delta T. And I'm just going to show it to you here. And it's just a little graph here. And so we have positive delta S, negative delta S. Horizontal, we have positive delta H, and we have negative delta H. And then over here to the side, I'm going to put a little squiggly line and put my arrow up here. And this is the temp. So we have a high temp and we have a low temp. And I know that's kind of a generic high and low temperature, but there's not really a number to put over there. So if I go into the upper, let me go start with this quadrant right here. If you have something that has a positive delta S, and you can look in a chart and find this, positive delta S and negative delta H, it is always, that's an A, always a spontaneous reaction. Always spontaneous, and spontaneous means it's a negative delta G. If you have something that's a negative delta S, that means that it becomes more disordered and it's endothermic, positive delta H. It's never spontaneous. That means you can try and kickstart this reaction. It's just not going to happen on its own. You're going to have to give it energy the whole entire time so it's going to work, right? The other two are temperature dependent. So if you have a positive delta S and a positive delta H, what you have is spontaneous, that's a negative delta G, if and only if it's at high temps. Here's your high temperature over here. And then down here, it's spontaneous, that's a negative delta G, if and only if it's at low temp. So you have this chart, and on the AP test especially, that'll be a really handy chart to do. But this is a way of thinking about it. If you can memorize this chart, then a lot of times it helps you to get your mind straight on how to deal with these weird kind of reactions that we have here. Okay, the next thing then, when we talk about this chart, that's a big question. Is it spontaneous? And that's exactly what this chart's for. Is the reaction spontaneous or thermodynamically favorable? The last thing we're going to talk about is Hess's law. And Hess's law says that the total enthalpy, remember, enthalpy is the heat associated with a chemical reaction or process. The total enthalpy, again, that's delta H, is the sum of all the chemical changes. Sum, just add it up. And pretty much what this does is it lets us add and subtract and multiply even reactions to get their new reactions and enthalpies. Okay, I'm going to put add and subtract, multiply, divide, chemical reactions to get new reactions. New chemical reactions. So, they can't possibly put every single chemical reaction in the books, right? They can't, on the charts and stuff. So there are sometimes we have to add and subtract the different chemical reactions to come up with a new one. Kind of like in your math classes, you guys have added and subtracted equations, like you've got two different equations and you combine them, and that ends up coming up with a third equation that looks totally different from the first two. We can do the same thing with chemical reactions. And so we can add and subtract the reactions to get a new reaction and the new enthalpy. Okay, so we'll do some of these. I have some papers in your packets and stuff. We'll do some of these and also write make some videos for each paper so that it gives you an idea of how to do these things. But this is the AP connection. So it's kind of out there a little bit, but it's something that the more I can introduce to you now, the easier it is to deal with it when you get into an AP chemistry class.